Okay, now we're recording. All right, so anyway, what we have now are square roots. So in this section, what's going to happen is we're just going to basically review what a square root is. Yeah, okay. If you can't see the notes or you can't hear me, just let me know. We're going to then see how to simplify a square root, okay? So we're going to see what a square root is, then we're going to simplify a square root, okay? That's the next thing we're going to do. And then this is something I've done in the past when I've taught with my math lab, because my math lab has you put the answers in. You have to rationalize the denominator of a fraction. Now, of course, with Lumen Learning, as far as I know, you don't have to do that, but I still think it's a good technique to know. So I will cover that as well. It's really not much to it. So, all right. Anyway, so first let's see what a square root is. So by definition, we say that the number b is a square root of a if b squared equals a. So b is a square root of a if b squared equals a. Again, that's just a definition of what it is. So I gave some examples here. For instance, 3 is a square root of 9, right? Because 3 squared equals 9. What else is a square root, though? Negative 3, because negative 3 squared is also equal to 9. So both 3 and negative 3 are square roots of 9. Same thing with 25. Namely, 5 is a square root of 25, right? Because 5 squared is 25. Negative 5, though, is also a square root because negative 5 squared is 25. So we actually have 2 square roots here. Okay, well, if we have 2 square roots, then one can ask, which is the one we care about, so to say? You know, which do we use? Well, that's where this comes in. We have this notion of the square root, the principal square root as it's called, okay? The principal square root of a. And by definition, not by definition, it's denoted by, here, let me get the laser thing up. It's denoted by this, as you can see. And it's by definition the non-negative square root of a. In other words, we have b is the square root of a if b squared is a, if b squared is a, and if b is non-negative. That's what this is about. So b is the square root of a if b squared is a and b is non-negative. So it's the non-negative square root of a. I mean, if you went back to these square roots, right? We had 3 is a non-negative square root of 9, but it had a negative one also, negative 3. So the non-negative one here would be the square root of 9. Likewise for 25, 5 would be the square root of 25 because it's the non-negative square root. I mean, I didn't use that notation here, but I could. And the other square root is just negative the square root of a. So this is the other notation, negative the square root of a. So that's what this is. Right? So again, what's nice is once you get the square root, the other one you just negate, which is nice. So for instance, going back to this, we have square root of 9 is 3, right? Now that's since 3 is non-negative, and 3 squared equals 9. So 3 is, again, the square root of 9 is 3, since 3 is non-negative, And 3 squared equals 9, as we can see. The square root of 16 is 4, okay? And that's because 4, well, for one thing, 4 is non-negative, right? So again, we're just unfolding this definition. 4 is non-negative, and 4 squared is 16, okay? 4 is non-negative, and 4 squared is 16. That's what we get here. And same thing with 25. We know the square root of that is 5, right? Because 5 is non-negative, and it's a square root of 25. So 5 squared is 25. That's what we get. All right, cool. That's good. That's good. Okay. All right. So that's what the square root is. These are just, some examples of it. And I restated the rule here. I did email everyone the notes, so you should have the notes with you. We have here, okay, what we have here, I just restated it for emphasis. So basically here we're saying b is the square root of a exactly when b squared is a and b is non-negative. Exactly when b squared is a. So b is a square root of a and b is non-negative. Again, it's just the square root that is non-negative. That's all it is. And that's really what I'm trying to say here. B is the square root of a exactly when b squared is a and b is non-negative. So when you see the square root thing, it has to be non-negative. In fact, this symbol here, this is what we call a radical sign, okay? This is what we call a radical sign, right? And actually what you're taking, what's under the radical sign, like over here, for instance, we have a here under the radical sign. We call that the radicand. So the square root symbol is a radical sign, and what you take the square root of is the radicand. So that's what this is equal to. All right. So it's just notation that people use. Also, what was I going to say? Also in the textbook, they do other radicals as well. They do like the cube root. They do something more general, namely the nth root. For time consideration, I'm only focusing on the square root. So that's what we're dealing with. I forgot to mention this also. Here I said the square root, but notice in parentheses, we said principal, right? Well, we said principal. People don't really say the principal square root. People generally just say the square root. So when you hear the square root, this is what they're talking about. Okay. All right. So over here, here's some more examples, right? If you take the square root of 121, right, what we get is 11. Now, why is that true? Well, on the one hand, 11 squared is 121, okay? And not only that, 11 is non-negative. So 11 squared is 121, right? So the square root of 121, it's 11 since 11 squared is 121, and 11 is non-negative. Below it, we have this, right? Well, this is actually false. The square root of 36 is -6. That's false. I mean, -6 squared is 36, but -6 is negative. We don't want that. Okay, square roots have to be non-negative. Square roots have to be non-negative. Okay, now. What's the right way to write? The right answer though is this, not -6. It should be 6. This is true. Okay, and that's again. It's not only is 6 squared 36. 6 is non-negative. Okay, 6 is non-negative. Good, good. So that's what we get here. All right, so that's what we get here. Now, and this is just something else that came up that it's good to know. The square root of something, this is only going to exist if the radicand is non-negative. So since we're only dealing with real numbers, we're only taking the square roots of non-negative numbers. So radicands here can only be non-negative for square roots. If we were working with complex numbers, then we would take square roots of negative numbers, but we can't do that here. So this is only going to make sense if a is non-negative. It actually comes from previous slides. From here, for instance, from here we have a has to be b squared, but if you square any number, you have to get something non-negative. So that's where it comes from.